Hi everyone, my name is Thomas Kim. Before I start this episode, I would like to recommend you Mr. Jeff Suzuki's YouTube channel. Jeff Suzuki is a professor at a college. He teaches mathematics through YouTube. He has lots of cool videos, simple to advanced level mathematics. In my case, for example, I learned a lot about cryptography by watching his video on cryptography. Before I began to watch this series of videos, I knew nothing about cryptography. By watching his videos on cryptography, I could implement RSA algorithm from scratch. These videos are very useful, and he has lots of cool videos about advanced mathematics too. Today is July 2nd, 2019. This is my 44th episode about the future of C++ programming, C++ 2A standard. In this episode, we will learn about functional programming paradigm or style and non-type template parameter. For more about functional programming style, please refer to Wikipedia. In this web page, you can read more about functional programming. I do not know much about the functional programming paradigm, and I read these documents not much, just introduction part of this document. In functional programming paradigm, for a given input, the function should always return the same result. That is, the function should not have side effects. Simply put, the function should not modify the state of global variables and the state local static variables. Second, the state of data should be immutable. That means we can initialize a data, but we cannot assign a new value to existing data. Simply put, we cannot modify the value of the data. I've thought about Fibonacci series for this episode, but I changed my mind and I will use Pascal's triangle as our example for this episode. If you want to learn more about Pascal's triangle, please refer to this video. Pascal's triangle is very useful to generate or enumerate subsets. By constructing subsets, I could implement most algorithms in the theory of automata. If I couldn't implement algorithms for set operations, I could not implement algorithms in theory of automata. By implementing operations for set theories, I could understand and implement most algorithms of theory of automata. For example, by using set operations, I could implement minimization of DFA and Myhill-Narrow theorem. So, Pascal's triangle can be very useful not only just for combinatorics, but also for theory of automata. If you start Visual Studio Code and open CPP extension folder, then you can find the tutorials folder. Click this tutorial folder, click this button, 044 functional.cpp, hit enter, Ctrl V, Ctrl plus, include IO stream, auto, this is reference, cout, std, cout, auto, end line. I will simply do this. For your convenience, this is Pascal's triangle formula. N C R equals n minus 1 C R minus 1 plus n minus 1 C R. Template size T and size T R. Struct Pascal triangle. Context sphere static size T value. We are initializing value here. It should be static and context sphere. In functional programming paradigm, once we initialize an object, we cannot modify its state. So, keyword context sphere makes value immutable. Pascal's triangle n-1 r-1 has member value plus Pascal's triangle n-1 r value. Please compare this equation. This is the part. Copy this part plus n-1 C R. Please note that n is constant expression or compile time expression. N and R are constant expression or compile time expressions. We cannot modify the values of n and r, as in functional programming paradigm. Once the values of n and r are initialized, we cannot change their states. This is not working. This is impossible. Okay? We cannot modify the value of n. So, this is the way we compute n-1 C R-1, this part. And we use recursion. Functional programming is based on recursion. So we are using recursion. Now this is specialization. I copy this part. This is primary template. Primary template determines the number of template parameter, which also, since the primary template class takes 2 parameters, so we have to provide 2 parameters. This is for the case n, cn, which is always 1. Okay, so here context sphere static size t value equals 1. Now I copy this part once again. Now n is 0. This case is also 1. Context sphere static size t value equals 1. Now we copy this once again. This is the case. Okay, this is n. Now we can create a function template type name n, size t n, size t r, context sphere size t, Pascal. Pascal's triangle. N R value. We are using this class, this struct. Okay. Now let's test this function. Void test Pascal triangle. Cout pipe C 0 Pascal pipe 0 enter std enter. We will just say enter because we defined enter here. Simply carries return. We can define another one. Then 2 carries return. I will copy once again. Copy, paste, 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 paste. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. int main. I will call this function. Start command prompt. You should be in CPP extension tutorial folder. CL EHSC STD C++ 17 044 functional CPP FE AEXE hit enter CLS A. So 5 combination 0 is 1, 5 combination 1 is 5, 5 combination 2 is 10, 5 combination 3 is 10. Now double check it. Binomial coefficient So 1, 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. This function works properly. Do you like this style of programming? I don't like this function. So let's create static loop. Template, size t, start r, size t, and r. Struct, static. Please note that we are creating a struct, then template, size tn, static, void, print, Pascal, triangle. We are creating a static function. If context pair start r less than or equal to and r, please note that r and r we used less than or equal to. Here cout n comes from this parameter. C, we use this start r equal, we use Pascal and start r. Then and there. If context pair start r plus 1 less than or equal to and r, then we call this function recursively. Static loop start r plus 1 and r. Please note that this is template function, so we have to give keyword template. We call this function again. It takes template parameter n. So n. We are calling recursively. We are calling this function recursion. We are calling this function recursively. With this, I will create another function, template, size t and void print Pascals. Again, we are calling this function like this. Static loop. It requires two parameters, start r 0 and r will be n. This is template. We are calling this function. We have to provide parameter, template parameter n. Okay, n. Now in this function, I will disable it. Cout n for C, I would say for C and Print Pascal's for print Pascal's 5. These are 5 elements. I say combinations with 4 elements. Combinations with, this is for 5 elements. Combinations with 6 elements. Now we build CLS A. So 4C01, 4C1, 4, 4C2, 6, 4C3, 4. Like this. This is 6, 4, 5C0 and 6C0. You can examine with this table. In case of 6, 1, 6, 15, 20, 15, 6, 1. 1, 6, 15, 20, 15, 6, 1. We can try with 8. Like this. This is 6, 7, 8. 7, 7, 8, 8. We build once again. CLS 8. So, in case of 8, 1, 8, 20, 56, 70, 56, 28, 8, 1. 1, 8, 20, 28, 56, 70, 70, 56, 28, 8, 1. So everything works fine. In my YouTube channel, Type Function and Modern C++ Programming, most algorithms in this series of video are implemented using functional programming style, especially episode 17 through episode 30. Most algorithms are implemented functional programming paradigm. I will give you a homework. Fibonacci numbers are defined as below. F0 is defined to 0. F1 is defined to F1. If n is greater than 1, then Fn is defined to be Fn minus 2 plus Fn minus 1. So this is recursion. In case of C and R, C and R, it is defined C n minus 1 R minus 1 plus C n minus 1 R. Okay, so if you compare these Fibonacci numbers and Pascal tree, Pascal tree is more complex than Fibonacci numbers. So please implement Fibonacci numbers in functional programming style. I will upload complete source code of this episode in extension talkplayfun.com website. By clicking this link, show in folder. If you unzip downloaded the zip file in CPP tutorial folder, you can find complete source code. Please subscribe to my YouTube channel. Thank you for watching.